I'm here to talk about overview of API management architectures. So I want to start with, you guys are probably very familiar, but just to set sort of frame of reference, APIs are experiencing explosive growth. This is a chart from Programmable Web. They call themselves a de facto journal of the API economy. They've been tracking the growth of evolution of APIs since 2008. What's interesting is, last February, it has hit close to the 20,000 mark. On average, 170 APIs, and these are just external APIs. External APIs, on average, 170 APIs are added since Jan 2014, right? Again, nothing surprising here, but thought this is an interesting stat. So you can go to their website and actually search, maps, food, traffic, all kinds of public-facing APIs. Another interesting stat: 83% of internet traffic is API traffic, according to Akamai's State of the Internet Security 2019 report. And APIs as a source of revenue, Salesforce, way back in 2014, 50% of Salesforce's revenues comes from APIs, and Expedia, 90%. So again, I think many of your enterprises, they're heavily involved with monetizing APIs. Just thought these are great examples. All right, so let me start with what API management is, right? Some sessions in the morning, they kind of alluded to API management. API management basically entails all aspects through the entire life cycle of an API, right from definition, publication, so defining the APIs, what kind of APIs do you want, and publishing it to, whether to be consumed internally or by external folks, by external developers. Security is key. Security entails authenticating, authorizing API clients, the mobile apps, whatever apps are consuming your APIs. The what I call, the entry point itself, meaning ensuring that there's no DDoS attack. A client is not just making all kinds of API calls that's resulting in a DDoS attack. And of course, ensuring the security of your upstream, the actual components, the actual services, backend services that are performing the business logic. So sort of three broad components to API security. Traffic management, I'll go into more detail in this presentation. Actually managing API traffic, mediating the API calls. When an API call is made, routing it to the right backend, right microservice, right, whatever the architecture you have in place. It also handles certain elements of security. I'll talk about that. Ongoing monitoring and maintenance. Once your APIs are now defined, you've established, you've sort of secured, all aspects of the API touch point. How do you monitor them? So, when do you experience a slowdown? Why is there why are there so many errors for this API? Typically, it's the I&O, infrastructure and operations, IT ops folks that are interested in the monitoring aspects. What is the health of our upstream servers, the backend services that are actually performing the business logic? Analytics. So there's monitoring, which entails a lot of looking at charts, graphs, and all. Then there's analytics. So analytics, there's a new role, API product manager. Many enterprises are sort of introducing this new role. This person, his or her function is to make sure that the APIs that are produced, they meet the requirements of the API consumers. So, whoever is consuming, whether it's Uber that's consuming Google Maps APIs, make sure that the requirements of Uber are met, and internally it meets the business objectives of the enterprise itself, of Google itself. So, who are the top users of the APIs? Who are the top developers? How is API traffic trending over time? When do we see a slowdown again? Which APIs are used most? Which APIs are used least? Those are some kind of analytics that this person would be interested in, so that it's an ongoing process. So the next revision of APIs, next version, next round of, they are much better used. You don't have as many unused or underutilized APIs. That's what this person's role is, and API product manager would be interested in all of these analytics. This person is also typically involved in ensuring a frictionless experience for the end users, for the developers that are consuming your APIs. That gets us to the onboarding dev portal. I think you guys are probably familiar. Dev portal usually has catalog of all the APIs that are actually exposed, some sample code, documentation, really enabling quick onboarding and reducing the learning curve, right, for somebody that's consuming your APIs. So that's sort of broadly what API management does. So now let's get into the architecture, right? That's what this session is about. So there is, so API client is making a call. There's a data plane, as I mentioned. There's the API gateway that's mainly involved in, that's the sole function is to mediate and route calls. But there's also all of these other aspects that I talked about. API control governance, API monitoring. There's also other functions that I've added, API transformation. So, SOAP to REST, XML to JSON, HTTP to JMS. So that's API transformation. API monitoring, I talked about. API control governance. Can this client access our pricing APIs? Can somebody with an app that's built, an Android OS, can it access any of our systems, right? So that's where control governance comes in. And also internally, does a developer have access to this particular API? Can a developer actually just publish this API, right? Publish an API, right? My point is, so a centralized control plane data plane, whenever a call is being made, it goes through this sort of entire, all aspects of the API management. Typically, there's a database involved that does the routing, content-based routing, fine-grained access controls, as I mentioned, who has, which client has access, what kind of privileges to a particular API. Quota management, rate limiting. I kind of talked about security. So, one of the examples I gave was DDoS attack. So you can apply rate limits, only a certain number of calls or certain number of requests per second. Also quota management, certain number of calls per hour. That ties in with SLA as well. So all of this is also involved. So there's a database that sort of keeps track of all this. Typically, when an API call is made, there's a lookup that needs to happen in this database to ensure that the rate limiting is not violated, right? And load balancing as well. So these are sort of traditional API management tools when they were mainly designed for handling north-south traffic. Typical example again is, although Uber and Google Maps are, sort of new, they've been around for some time, but that's a typical example I give, right? No, Uber is an application that's outside your data center that's trying to access Google Maps, information from Google Maps, which is inside your data center, Google being the company of reference. So that's sort of a centralized data plane, control plane. Rise of microservices, again, I think I've been halfway into the session. You guys are probably familiar with microservices, but let me just give a quick recap on how that ties in with API management, right? So you have the monolithic application. You guys are probably familiar, 3-tier, client server, SOA. Break it up into, it's an approach to software architecture where you build a complex application like what's on the left, but with smaller components that perform one function only, passenger management, driver management, inventory, whatever the case may be, right? The benefits, and most importantly, for the purpose of this presentation, the communication between these microservices they typically occur using REST APIs. The benefits are numerous. You're giving your developers a lot of independence. First of all, it's easy to develop and maintain these smaller chunks of code, smaller services. You are able to scale easily. In order to scale a monolithic app, in order to scale a microservices app, rather, you just scale 1 or 2 services. Fault isolation is improved. If there's a memory leak, it's very hard to debug, as we all know, a monolithic application than if a memory leak happens, it's only contained to that particular microservice. So there are lots of benefits, right? But again, the key point to remember is all of the communication happens using REST APIs. So given that, let's talk about a microgateways for microservices. I think we've had a lot of discussion about microgateways. So you have typically, by the way, DevOps is also involved when there's a microservices initiative. The enterprise is basically modernizing not just their applications, but also their processes. As I mentioned earlier, each and every service can be developed by a certain group of developers, and DevOps comes in play. But the sort of that's called typically an edge gateway. The edge gateway can handle the TLS termination, routing to various services, and rate limiting as well, as I talked about. The microgateway performs service discovery and authentication per API. So that's interesting because in this case, for example, microservice B you need to configure microservice B, or it should be written in a way that microservice C can be accessed through this microgateway C. There should be a C there. What I'm trying to say is, and by the way, there's also in order to authenticate, how does microservice C know that it is in fact microservice B that's trying to access microservice C, right? So you need to think about dynamically authenticating and authorizing credentials. So what I'm trying to say is this is a good approach. This microgateways, first of all, they can be deployed on containers. They're lightweight. So as you try to manage east-west traffic, they're a good solution. But it comes with challenges in the sense that authentication becomes a challenge. Each and every microservice can have its own authentication authorization mechanisms. And there should be another, how are you going to actually determine, how are you going to first look up what authentication is needed to access this microservice and be able to do that in a reliable fashion, right? There is sort of a danger that the microgateway can actually take on a lot more functionality of a typical gateway, in which case it's not a microgateway, right? That's where I'm going at. But again, I think especially traditional management solutions, they were designed for north-south. There were no containers, or it was just not that prevalent when they introduced their solutions. This is a sort of approach, sort of a graphed-on approach to handle microservices, to handle containers, and all of that. So now let's go back to the diagram we saw earlier, the decoupled data plane and control plane. This is what we saw earlier, centralized control plane, data plane. Now let's talk about decoupled, right? So this is an approach where the database goes away. So when you're just for processing calls, you still have the control plane. You still have the control plane that does all of these functions, API management functions. But to process API calls, I'm talking only about processing API calls, you don't need the database because all of the rate limiting, quota management, fine-grained access control, all of that is handled by the gateway itself. It's handled in memory. You don't need a database. And by the way, database is a proxy for a complex architecture, right? You have databases, you have message queues like Kafka, the Zookeeper. There's about 5 or 6 components at least in that gray box. For simplification purposes, I've just pointed out the main functions. And this looks nice. You still have to have a control plane, again, just to reiterate. You need a control plane to do all those things, and the control plane has its own database to do monitoring and all that, and to perform all those functions. But to just process a call, you don't need to look up a database to do rate limiting because it's handled in memory by the gateway. Consequently, you have higher performance and the complexity of your architecture is reduced. Because the API gateway in this case handles all of these functions. TLS termination, as I mentioned, client authentication, fine-grained access controls, request routing, especially request routing in the case of microservices. You can imagine how you could be thousands of microservice calls, and all of that has to be stored in a database, right? Cassandra, Redis, whatever the case may be. And of course, API gateway, then rate limiting, load balancing, service discovery. So just to point out the advantages of this approach, you get high performance because there's no need for database lookup to simplify things. It is able to deliver high performance for both north-south traffic and east-west traffic, regardless of where the API gateway is deployed. The microgateway, sort of a microgateway, the architecture that we looked at before, you would still need the regular kind of centralized data plane and control plane for managing your north-south traffic. And then you will have to have a microgateway just for handling east-west traffic, right? So you kind of have two different architectures in place if you, of course, are embarking on microservices and all that, right? Here, that's not the case because you, again, get the API gateway, you can deploy it for every service, microservice. You can deploy it just as a load balancer to handle north-south traffic, and you're still getting the same kind of same high performance. No need for additional software components such as microgateways because this is a gateway and a microgateway together, combined. Smaller good footprint. Another point to emphasize here, your microservice itself is microservice. It's smaller. You can't have a gateway or a API management solution, huge VM, trying to manage traffic between microservices when they themselves are lightweight and operate in containers, right? And finally, it reduces complexity. But just to recap some of the deployment pattern options. So we looked at centralized control plane and data plane designed for mainly north-south traffic when API management was introduced as a solution, mid-2000s maybe. So great for monolithic applications, centralized governance, not really suitable for microservices, has a large footprint. Hybrid approach, suitable for DevOps teams, have high frequency updates. So you can, of course, have production environment, test and dev, whatever various different environments, and you can you can set up a microgateway for each of these environments. Very DevOps friendly, of course, lightweight, but it's yet another component to manage apart from the 5 or 6 other things that I was talking about. Authorization could be an issue. Decoupled data plane, control plane, it's got all the goodness of managing both north-south and east-west. It's lightweight, performant, but if you have, you can't integrate with an existing system, right? Traditional API management systems. So I'm from NGINX. NGINX is a open source web server, versatile piece of software that's a web server, content cache, load balancer, API gateway. That's why I'm in this conference. And so we basically are the API gateway. We power the API gateway for many of the API management solutions. Quick overview of our sort of portfolio. We, in the early 2002, I think, the original goal of our founder was to solve the C10K problem, being able to handle 10,000 connections concurrently. That's where it gained prominence. Today, we are the most popular web server. It was the origin. But then I'm doing it very efficiently with very minimal CPU and memory. As I mentioned, we are also that same piece of software. The data plane is a load balancer, content cache, WAF, API gateway. Sitting on top is our controller that you can basically program the data plane as a load balancer, application delivery, API management that performs all of the lifecycle that I talked about. And we also will be introducing a service mesh solution. We also have an app server bringing all of the goodness of NGINX, delivering high performance very efficiently, very efficient CPU and memory as an app server, not as a web server. and it can support multiple languages. So sort of a quick overview of our portfolio. That basically concludes my presentation. Don't know how many minutes I have.